Awesome. So hello, everyone. My name is Dylan Wootton. I'm a fourth-year PhD candidate at MIT, and I am going to be talking to you all about some of my work to visualize Arctic sea ice data today. In 1893, Fridtjof Nansen did something insane. He deliberately stuck his shipping vessel into sea ice. Now, Nansen did this because he was trying to better understand the dynamics of the Arctic, and he knew something that a number of other individuals didn't quite understand. 3 years before, articles of a shipwreck had washed up on the coast of Greenland. Now, this wouldn't be surprising. This happens all of the time. However, these articles appeared to be from a ship that had sunk on the complete opposite side of the Arctic Ocean. Now, many people wrote this off as just a mistake. These articles weren't authentic. This wasn't actually from that ship itself. However, Nansen thought that this was evidence of a transpolar drift that would take the sea ice from the part of Siberia all the way down to Greenland. So Nansen sailed his ship into the sea ice and waited. And he waited. 3 years later, Nansen emerged successfully on the other side of the Arctic, having completed a 3-year voyage all the way over back to Norway. This was an astounding success and revolutionized the way that we not only measured and mapped the Arctic, but also thought about it as a time-varying and dynamic system. Now, this led to a whole lot of different policies and practices in being able to record and measure sea ice. 3 years after it, the International Geographic Congress was so surprised by some of the results about sea ice drift, they began to record sea ice observations at a multi-month basis throughout the year. Now, modern days, we have the ability of using satellites to be able to capture data in pretty much real time. So what you're seeing here is that sea ice drift measured through these streamlines. And we can use this data to be able to look at both monthly patterns and how it changes across months, such as this in October. And we can also use it to be able to investigate how sea ice is drifting even inside of point events, such as this cyclone that occurred in the Arctic back in 2022. Now, sea ice drift data is very important for us to be able to plan our missions that are currently going on into the Arctic. And back in 2019, a team was using this drift data to be able to plan their expedition. The Mosaic expedition sought to recreate Nansen's journey by attaching themselves to sea ice and drifting with it to investigate the high Arctic. Now, what they found was an Arctic that would have been unrecognizable to Nansen. Where Nansen had carved through ice that was meters thick, they found sea ice that was only 10 to 30 centimeters thick. Barely enough to be able to support their observation stations. Now, this raises the question, how did the Arctic that Nansen experienced become the Arctic that Mosaic found? Now, this was a question that I was interested in answering back in 2019 when I was working with a group of sea ice researchers to better understand the spatial and temporal trends in Arctic sea ice decline. Now, initially, we were creating a lot of charts and visualizations to better understand how sea ice was changing over time, and a lot of them kind of looked like this over here. They were essentially these map visualizations where we'd be showing one slice of time. So this is data from March of 2014, September of 2014, or November of 2014. And while these were very flashy and we added interaction and animation to them, what we ended up finding that this wasn't particularly an effective strategy of being able to display these temporal and spatial patterns. That is, someone could look at a map and look at a point on it and have an understanding of exactly if there was sea ice at that point. But let me say, if I tell you to find the sea ice right here and how many times that occurs over a longer period, such as 20 or 30 years, and I give you like 30 of those maps, it's going to take a little while for you to sift through and be able to see how the sea ice changes at a given point in time in a location. And so what we wanted to do is better represent the temporal trends that were occurring inside of the data. So we went back to the drawing board, literally, and tried to think about how we could represent this data, not just using a map, but using other visualization techniques as well. We ended up landing on what we call a temporal ordered spatial matrix. You can call it a TOSM for short. It's essentially a heat map that shows how sea ice concentration varies over time as well as along a route. So what you're actually looking at over here is an example of one of those heat maps. Along the x-axis, it goes from distance along the route. So for example, this is showing information about a route from the Northwest Passage, which goes from Greenland all the way over to Alaska. And as you go further along the route, the cells encode essentially how much sea ice one encounters along the route at that point in time. So the first row corresponds to March of 2014, second row corresponds to September of 2014. So by looking at the pixel values and seeing all of the white inside of the first row, you can understand that that the sea ice typically would be blocking your trajectory if you were to take this path in March, whereas it is only slightly blocked inside of September. Now, using these visualizations, we can start to look at what Nansen's journey would have been like. Pulling data from 2022 all the way up until more recent data, we can start to see some of the temporal trends that occur inside of the Arctic. You can see this growing and shrinking pattern where sea ice grows all the way up until March and then starts to shrink during the summer months as the sea ice melts and open water takes place. Now, this was interesting because we could begin to start to see some of these monthly patterns. However, this doesn't necessarily tell us exactly what Nansen had experienced. But luckily for us, back in 2016, a group of sea ice researchers published a data set called CIBT 1850. This data set involved the researchers going through a ton of historical archives, including things such as records from the Royal Society, information about ice charts that were obtained from the various amounts of research organizations, as well as whaling logbooks to determine exactly where sea ice was at given points in time. Compiling all of this data together, they were able to create gridded estimates of how sea ice has changed dating back to 1850. Now, while these are estimates, they do give us a pretty good idea as to exactly what the Arctic looked like back then. Using this data set, we can begin to look at what Nansen's journey would have been like. You can see over here data from 1893 all the way down into 1896. For this, you can notice that the visualization starts to look a little bit different. That is, instead of having some of those smaller gaps inside of kind of the more recent data, we have a continuous through line of sea ice that exists all the way down until when Nansen successfully exited in 1896. Now, given the amount of development inside of how we forecast and think about predicting sea ice, there's been a lot of attempts to be able to create new data sets that give us projections of how sea ice will change all the way up to 2100. So pulling data from CMIP6, we've been able to get a look at what our future holds for Nansen's journey. You can notice inside of the forecast for the future that the summer months are becoming more and more open with sea ice, where there used to maybe be small gaps inside of the sea ice currently. There are now large gaps that exist over multiple months between freezing and thawing. Now, this is one of the expeditions that I was interested in looking at, but I was also curious about being able to investigate other data sets as well. In particular, I was interested in looking at the Northwest Passage. This is a famous route that explorers have tried to be able to cross for centuries and didn't successfully cross until 1900s. And so what you're seeing is essentially a zoomed out view of that data, where I was just showing you those kind of like 3-month segments before. I'm now showing you data all the way from 1850 to future projections of 2100. I faceted this out by month so that you can start to see some of these longer term trends rather than just the kind of monthly growing and shrinking of the sea ice. And a few things become evident as we look at this zoomed out view. Many of the months continue to remain covered in ice, even well into 2100. However, notably, the summer months experience a high degree of melting, which is as represented by the large amounts of blue further on down the chart. Now, I'm going to focus on the month of September here because this is an important month for sea ice researchers as it represents the annual minima of sea ice. If we zoom in just on that heat map about September, we can begin to see a little bit more detail that can help us understand how some of the sea ice is changing over time. In particular, I want to pay your attention over here to this kind of initial section of the heat map. So as you go across the heat map, this encodes information about different spatial locations along the Northwest Passage. And in particular, this area corresponds to Baffin Bay and along the coast of Greenland. One thing that you'll notice is that as we get closer into 2020, much of this sea ice that used to exist inside of summer months is going to be completely gone. This is going to have tremendous impacts because sea ice, particularly in this area, plays a large role in being able to stabilize the local climate. For example, inside of Greenland, many of the ice sheets, when they are exposed to warmer ocean waters and are not buffered by the sea ice, will begin melting at a faster rate. So these types of tools can allow for us to have a better understanding of what some of these regional trends around coastlines might look like. Now, these were just two of the hundreds of expeditions that have taken place inside of the Arctic. You are seeing expedition lines from a data set that was created by Andres Salvador that essentially shows all of these different expeditions dating back over 500 years. Now, I was curious about what some of these other expeditions would also look like here, which is what you're going to be seeing inside of this next slide. So what I'm showing you is data that extends for 36 different expedition routes. I've grouped them according to kind of general geographic region. You don't need to know particulars, but essentially Northwest Passage is down there, and a lot of the trips to the high Arctic are over here. I've shown you data from 1850 to 1860, and let's go ahead and see what happens as time goes on. Starting in 1800s, we are exiting the period known as the Little Ice Age, in which sea ice was at its maxima. However, as we go into the 1900s, things begin to change. We start to see a degree of warming from the period of 1920 to 1940, which is represented by the increasing amount of dark blue across many of these paths. As we venture into the later part of the 20th century, we start to get the ability to use satellite data to give us really fine-grained estimates of how sea ice is changing over time. In fact, in 1999, we end up seeing the first route no longer having sea ice, Edward Pullen's route. However, many other routes are going to be following suit. Coming into the later part of the 2020s, we begin to see that 80% of all of these expedition routes, which used to be blocked with ice, are now open water in September. As we come to the later part of the 21st century, we will see that no routes are projected to have sea ice. Now, when Nansen sailed his vessel into sea ice, he wasn't just going on a particular adventure and expedition. He was fundamentally changing the way that we were thinking about the Arctic. He was viewing it not just as a static system that needed to be mapped, but rather as a dynamic and time-changing system. To better understand many of the data sets that we work with, these spatial and temporal data sets, we need to understand both these components about space and time. Now, I think that maps are a really phenomenal tool, especially for being able to visualize those spatial relationships. However, through this project, what we ended up finding that maps were actually standing in the way of us to being able to visualize and communicate some of this data about how these routes were changing over time. Now, this isn't just necessarily about having pretty visualizations. The visualizations and representations that we choose are going to shape the ways that we think about our data. The patterns that we see and the insights that we don't find will be shaped by those choices. So, thank you.